Hello friends, welcome to simulation card. In this video we are going to simulate the simulation of sliding mode control based current control of switched reluctance motor. So this is the website from where we can purchase this model. This link is given in the description of this video, and if you want to purchase this you can click this link and you can purchase this. So this is available in Indian rupee as well as in US dollars. Right, so if you want to have one-to-one explanation with a developer, you can add this, and you can add this to the cart, and you can proceed on with the purchase with your local debit card or credit card. Okay, so let us get into the simulation now. So this is the model which we are going to simulate now. So here we are using the SMC controller, sliding mode control, to control the speed of this switch reluctance motor. So this is 8x6 switch reluctance motor, and these are the parameters of the motor. And the voltage that we are choosing here is 350 volts. And here we have the converters, and for all the four phases we are providing 4 converters, and the pulses are given to the converters from here. Okay, so let me explain this part now. So here we have the reference speed. The reference speed will be changing from 500 to 1000 rpm when the time reaches 0.5 second. So the speed is compared with the actual speed, which is calculated from here, and the error is calculated. The calculated error is given to the sliding mode control where we are doing the calculation. So here we have two things. One is the manipulation of the error. So here we have the actual error being manipulated with a gain value, and here we have the derivation of the error, and it is again manipulated with the gain here. So later on we are giving the error, the sum of the error, the sum of the manipulated value to the sliding surface. So here we have the sliding surface which will make sure that the speed of the motor is maintained well within the rated bandwidth. So the output of the sliding mode control will be the current, and with this current this will be a steady value, and in order to have the uh, angle, we are multiplying it with the angle calculated from the position sensor. Okay, so I'll come to that later. So here we are getting the magnitude, and here we are getting the direction, and this will be the perfect reference uh, of current, and with this current we are comparing the actual currents. So there will be 4 actual currents. All the currents are compared with the reference current, and the error is given as input to the hysteresis controller here. So this hysteresis controller will be producing gates for all the 4 switches here. Okay, and here we are having 2 values, alpha and beta. These are the angles. So here the speed is coming in terms of radians per rpm, and later on it is converted to radians per second, and uh, this conversion is to convert this to angle, and here we are finding out the modulus, and finally we are trying to find out the angle of all the 4 currents. Okay, so let us run the simulation now. Yes, the simulation has started. We shall see the speed. Yes, so at this point in time it should move to 1000 rpm. Yes, so it is settling perfectly at 1000 rpm. So our SMC is making sure that the speed is perfectly being tracked, and here we have the current. These are the current waveforms. So as you can see here, uh, the frequency of the current waveform is getting increased as the speed increases. So this is applicable for all the four phases. And this is the waveform for flux. Here you can see the fluxes for all the four phases. Okay, so thanks for watching. Please download the model if you want, or if you can, if you are interested with this model, you can please share this model to your friends, and please subscribe our channel. Thanks for watching.